Hello, Brent here with the Colorado Printing Project, and I was hoping to make it out to Teardown in Portland this weekend, which sounded like a really neat get together, but unfortunately I wasn't able to, so instead I've decided to tear apart one of the new long block versions of the Twoolhead and just kind of show you guys how these things are built. So yeah, I guess we'll get started. So I'm going to start by removing this upper brace, which is also an adjustment bracket. You can kind of see there's slots underneath this side. And that's so that when this side of the tool head, you can rotate it to bring this nozzle up and down, and that's how you get them at the same height in Z. So start by popping that off. Just little flathead M3s. I decided to, everywhere that it's possible, to use metric blue fasteners, which are just stainless steel fasteners that are dyed blue. I just think it's kind of awesome that these even exist, and since I'm making small batches, the cost difference doesn't actually amount to much. So I went for it, and I think it looks really nice with the purple and black, and yeah. So on this side, these are just oversized M5 washers that I have with sort of the smooth side down. There's always a smooth side and a flat side, or a sharp side to washers, just from the way they're stamped. And I have that down so it doesn't cut into the plastic, and you can adjust sort of that position over and over again, and then lock it in place. So that's kind of the thinking there. Undo that one. Get bearing on it. That's good. This one, I think some plastic got into the thermal insert. Normally they don't sound that way. Okay, so that brace is off. Now we need to take off the next one. So this brace has slots on both sides and actually is also the heatsink fan. So we'll get that guy off. And so these are just two 5-volt fans that are connected together. I'll show you that connection in just a second. But so they're just always running whenever the machine is powered. So there's no logic going on there. It's just when the machine's on, these are running, and they're keeping those heat sinks nice and cool, which is good. Got that off. I can kind of show you here the way that they're joined. Those are little solder sleeves. So it's a nice waterproof, very highly conductive joint for joining wires like this. So that's off, and now the only thing connecting them is a couple wires and this back plate. So we'll get that off, and then we'll be able to separate the two, and I can tear down like the individual extruder hot end assembly. I guess while we're on the back side, we've got this little switch hitter mount here. And that's just so you can adjust the X position, so that'll run over and hit the little end stop switch, and you can move it farther in or farther out to just set your position. Back here we've got two flatheads on this side, so that locks this one in place, and then a flathead that it pivots, this side pivots around, and a button head so you can just lock it down. So pop those out. Yeah, the metric blue fasteners, I guess they were created when I think one of the big US auto manufacturers started having a lot of metric in with their tooling because of globalization and all that. So they standardized that anything metric had to be dyed blue, so that you could tell what you were working with. If it was like a mold or something that might have multiple, I guess both metric and standard. anyway, it's kind of interesting, and it's neat that you can still get these. I think recently it switched to, I don't know, if you paint the standard fasteners and metric or just regular stainless, something like that, I don't know. So now I'm undoing the 24-volt cooling fans, which also join the two sides together. Those are also just solder sleeves here. So they always run just exactly the same amount of power to each one. Okay, how are we going to... I guess I can pop these fans off to just take it off of the plastic piece. Got that. Got those. Put the zip tie. I do love zip ties. Okay, so you got your plastic piece with just some thermal inserts in it. This is pointed with, or printed with a 0.8 nozzle, so it's nice and strong, and I think it only takes like 30 some minutes for 2 of these, which is pretty epic given the size. So now what's still attaching these together? So there's, you can see that wire in there is a sense line. Basically the way that this sort of finds where the bed is so it knows where to print is it goes down and makes electrical contact between the nozzle and a washer on the side of the bed. And that's really handy because then there's no offset between sort of like your nozzle, which is going to be doing the printing, and what you're measuring the height with. Lots of printers will use a switch that dips down or an inductive sensor or something, but then you have that sort of offset between the two, and that's unfortunate. So that's kind of the logic behind why we have this sense wire and why we do leveling the way that we do. Okay, got that off. And now we'll have to see if we can unscrew this sense wire. So it's a high temperature wire with a little star washer between it and the block. So that just gets you really nice, good thermal conductivity. And then I think we'll also need to remove this hot end because the wire is actually running up out a slot in the back. So undo that sucker. Alright. So here we've got our mount. This is a modified mount. So basically the standard tool head will have one that's just flat. This one's heightened just to keep the nozzles at the same height even though you have this really long melt zone. This is the hot end that you'll get in the 0.5 or 0.8 millimeter version. You can see how much size difference there is there. And that's just basically you want to tune the, it's called the melt zone, which is everything from the top of that heater block to the tip of the nozzle, which is where the plastic's actually melting. You need to sort of increase or decrease that to get to match whatever filament flow you're going to have. So I guess that's why you'll see different length of blocks on different printers. It's just basically how fast you expect to be pushing plastic through. So just pop that hot end out. Good, good. Now, I think that these should be pretty much separated if I can get the wires untwisted. I'll take off that fan. Pop that guy off. And these are Polonus, just the exact same fans that you get on the standard Voltbot Mini, which is really important that you keep those. It's like just using a 24-volt fan isn't quite enough because you will get different flow profiles between different brands of fans. So that's why we added a little bit of cost and went with actual Polonus fans. Sorry about the phone ringing there. Cool. So now we can get this one off as well. And then I can just do a little teardown of the Wade's extruder itself, which I guess we don't need to do twice, so I'll just do that on this side. So, for those who aren't familiar, this is what's called a Wade's. It's like the Greg's Wade's Jonas Squaling whatever AO. It's an older design, but it is rock solid. I love it. It's got a 5.2-ish to 1 gear reduction, so you can use a nice small motor but still just push a ton of filament at relatively high pressures. Herringbone gears, so you get nice alignment and very little lash in those. And my favorite part of the Wade style extruder is you just pop this open and you have like full access to feed filament easily down into that hole. You can see the hobbed bolt, which is down in there. It's got some teeth cut on it to feed the filament down. Overall, it's just a rock solid design. It's been around for a long time, but it is still my favorite extruder design. So that's kind of why that's still used. So undo this. Just a couple springs and then this latch. You can adjust the tension, but typically you don't need to. So when you're setting it, it's good to set it so that the washer is just flush with that sort of raised bit. That's what that's for. Just to try and tell you how tight it needs to be for 99% of filaments. Usually if something's wrong, that is not it. And this is your little idler, just a little basically skateboard bearing in there on a little rod, and that just pushes up against the filament to give you good grip. And yeah, so I'll pop off the stepper motor.